video, we're going to talk about another most important, trigonometric function problems. And the question is, solve for the tangent of x when the point A is overlapped to the point C in the rectangular shape. So what is the thing that we need to solve in this question? Well, the basic thing that we need to solve in this question is to solve the tangent of our x degrees. So in order to solve for this question, we need to know three main things in order to approach this question. And the first thing that we're going to talk about is the origin of our trigonometric function. The most important thing here is going to be a trigonometric function. So let's think about where did the trigonometric function originate from? Well, as we talked about this in a lot of videos, the most important thing in our trigonometric function will be a right triangle. This is the only thing that we can apply in our right triangle. And what is the another most important thing in our right triangle? Well, it is going to be an angle given. So using these two things, we can apply our trigonometric function. But before that, we're going to need our right triangle in order to apply this trigonometric function. So let's have a look at the right triangle. So the first thing that we're going to talk about in order to think about a trigonometric function will be if we can apply through our right triangle. So here's our triangle, and what makes the difference between just a triangle and a right triangle? Well, it will be defined by the word right, which means what is the definition of a right? Well, in the angle, that means it is a 90 degrees. And what is the thing that we can show that it is a 90 degrees? Well, we can draw a small square form to our angle that is perpendicular together, and it is our 90 degree x. So here is our right triangle. But what is the most important thing in our trigonometric function? Next one will be our angle. So before we think about the trigonometric function, we need to kind of do a setup in order to apply our trigonometric function. So we'll be able to have a angle. So let's just say that this angle is our x degrees. And what is our x degrees? It will be our main angle, the main element that defines our trigonometric function. And another most important thing is label every single size. But every single size will be defined by this x degrees. What is x degrees? It is a main angle. So let's think about let's think about this side right over here. What is this side about? Well, it is a side that is opposite with our x degrees. We're always thinking about this size or every single element in our right triangle through our main angle. And our main angle will be our x degrees. So this will be an opposite side. What is this side right over here? Well, that side is close to our x degrees, which is our main angle. So we'll just notate it as the adjacent side of our x degrees. And now we have our last side. What is this side going to be? Well, a lot of people will be confused with this element because it is also adjacent side with our x degrees. But how can you make a difference between them? Well, so people made the definition. So we'll call this side, the hypotenuse. We'll call this side hypotenuse. And why do we call this hypotenuse? Because it should be a longest side in our right triangle. It will be a longest side in our right triangle. And how can you say that? How can you define it every time? Well, it should always be opposite side with our right angle. This is what the hypotenuse will going to be. So this is this basic setup that we did in order to solve or apply our trigonometric function. So the first trigonometric function that we're going to talk about is, the first thing is, what is our sine of x degrees? Well, we need to think about in every single trigonometric function values always contain our specific main angle. It's our x degrees. So what is our sine of x? Well, the similarity between each trigonometric function is that they all have our division side, which is kind of a fraction. The definition of our sine of x is it is a hypotenuse in our denominator, and in the numerator there will be a opposite side in our numerator. That's what our sine of x will going to be. So the opposite side What is our opposite side? It is a side that is opposite to our x degrees. And what is our hypotenuse again? Well, our hypotenuse is the longest side of in our trigonometric function right angle. This is what the sine of x will going to be. So now let's think about the second one. The second one that we talked about this in a lot of videos. What is our cosine of our x degrees? Well, it also contains our main angle. In this case, we're going to be our x degrees. So you should always have a division side, which makes it as a fraction types, but not really. So it also contains a hypotenuse in the denominator. That is the main similarity between the sine and the cosine of x. And in the numerator, instead of the opposite side, we're going to have the adjacent side. It will be an adjacent side over a hypotenuse. And what does this mean? Well, the adjacent side means it is a side that is close to our main angle. What is our main angle in this case? X degrees. And what is our hypotenuse again? Well, hypotenuse is a longest side. It is a longest side. It is the longest side in our trigonometric function triangle. So this was our cosine of x. And there are last trigonometric function values. What is it? It will be our tangent of x. Well, the most important thing is that we always have to never forget our main angle. And what is the tangent of x? It is a little bit different with our sine or cosine. So I will write it in a different color. Let's write this with our red one. So they are all the same that we write a fraction to create a fraction, or we can say division. But in the numerator, it will going to be the definition of our tangent of x is opposite side over all of them over a adjacent side. What is the difference between sine, cosine, and tangent? Well, we know the sine and the cosine, they all contain a hypotenuse in their denominator, but for the tangent of x, it doesn't. It is just going to be a opposite side over a adjacent side. This is the most different. Or I can see the biggest thing that differs between the sine, cosine, as well as the tangent values. So there are totally three things. So I guess we can draw it again in a more neat way. So this is a thing that we contain. And what do we call, if we add all of them, we call this as the trigonometric. We'll call it as a trigonometric function. Trigonometric function values. And I forget one more thing that we're going to talk about a little bit more about the tangent of x. We know that opposite side over adjacent side is our tangent of x. So we can simplify it in a different way. Well, what is the opposite side? What is the opposite side? Well, we usually the opposite side, we usually notate it as our sine of x degrees. Now, what is the adjacent side? Well, the adjacent side, which is located in the denominator of our tangent of x, we call it as the cosine of x. And if we divide these two things and make it as the fraction, what do we call? We call it as the tangent of x. Tangent of our x degrees. And now we can convert our opposite side over adjacent side in a different way. Since we knew that opposite side is sine of x, we will make a division side again, but in a different way. In the numerator, there will be a sine of x degrees instead of opposite side, and denominator there will be a cosine of x, since we knew that is an adjacent side in our cosine of x. This is what our tangent of x will going to be. This is what the tangent of x will going to be. The sine of x, which is the opposite side, all of them over a cosine of x, which is our adjacent side. This is what our trigonometric function will going to be. So we finished our first thing, which means the origin of the trigonometric function. Where is these two things as well as the tangent originate from? Well, they're all originate from our right triangle. Every single thing that is related to our trigonometric function, we will always need to apply them in our right triangle. What is the most important thing in a right triangle? Well, the angle, the 90 degrees that defines or makes the right triangle, our right triangle different with just a triangle. So this is what the first one means, the origin of the trigonometric function. Now let's go to the second one, which is the definition formulas of our Pythagorean theorem. So we can see that this will be a third thing that we're going to talk about. What is the third thing? It will be a Pythagorean. It will going to be a Pythagorean theorem. And we might think about this in a lot of ways. Well, we know that this Pythagorean theorem, it looks like, what is the Pythagorean? Well, Pythagorean is one of the most famous mathematicians in the world, and it is a theorem, or we can say theory, that was created by a person called Pythagorean. And Pythagorean is also one of the most important things in our trigonometric function. Why is it important? Because they have a similarity. Firstly, the first similarity is that we can only apply them to our right triangle. And the second thing is the advanced one of our sine cosine, which is sine law, the law of sine, and the cosine law, which is law of cosine. They're all originated from our Pythagorean theorem. That's why we learn Pythagorean theorem, even though it's not important when it comes to solving this kind of trigonometric function values questions. So let's actually get through our Pythagorean theorem. And obviously we know that they're originated from our right triangle, so we can draw a right triangle simply. So let's make a mark for our right triangle to show that it is a right angle that makes the right triangle. And right now we are going to talk about what is the Pythagorean theorem. Why is it so important in a right triangle as well as trigonometric function? Well, the same thing with the trigonometric function. The most important thing in our Pythagorean theorem is label size. Well, in the trigonometric function, well, so we can say in this way, the difference between trigonometric function and the Pythagorean theorem is the trigonometric function. So we'll just say a trigonometric function. The most important thing, what was it? It was the angle, the main angle, which was x degrees in this case. And what is the Pythagorean theorem? The most important thing in our Pythagorean theorem? What is the most important thing in our Pythagorean theorem? So our most important thing in our Pythagorean theorem, unlike the first one, it will be a size. That's why this two, if we add all of them, we can say it is a full trigonometric function. So let's actually get through what is the Pythagorean theorem. So there is no angle exists. The main angle in this case will be our 90 degrees. And firstly, we need to label every single side. So let's just simply label this side A. The order won't be a matter because there is no main angle. And this let's say we call it as B. And let's call this longest side, I guess, C. And let's think about it in this way. What do we call A value? Well, we call our A value our legs. What do we call our B value? Well, we call our B value legs. Then what should we call our C values? Well, there is a difference between A, B, and C. C value, which is always should be opposite side with our right angle, it will going to be a hypotenuse. What is the hypotenuse? Well, it is a longest side. We're going to be a longest side in our trigonometric function as well as the right angle. So we define it like this. C value will be the most important thing, which we're going to be our hypotenuse. What is hypotenuse? Longest side. Now, what we're going to call B, well, we'll just call it as the legs. And what does legs mean? Leg is same thing with our sides, but we just call it as legs, or we can call it as size too. What is our A value? We also call it as our legs. So with this three, we'll be able to define our Pythagorean theorem. So let's get through. What is our formula for our Pythagorean theorem? So we will write as fourth. What is our formula for our Pythagorean theorem? The formula for our Pythagorean theorem will be a squared plus b squared will be equal to our c squared. What does this mean? What does a squared plus b squared c squared means? Well, this shows, so I'm gonna talk about definition first before we talk about any formulas. This formula for our Pythagorean theorem shows that it states that the square of the hypotenuse, what is our hypotenuse? Well, hypotenuse is the longest side in our trigonometric function, and the hypotenuse, the most important thing is the side opposite to right angle, and that is equal, or we can say equivalent, with the addition. And what does the addition means? Well, it's the same thing with the sum, which is the opposite with our subtraction. The addition of two other sides squared. And you might not know what this means. What the heck does this mean? The definition is the square of our hypotenuse. The square of our hypotenuse, what is the square? Multiplying each number to the same number of hypotenuse is equal addition to other size values. And what the heck this means? Well, this means in this way. If we write it in our formula like S, the hypotenuse square should always be equal to size that doesn't include our hypotenuse square plus the other size that doesn't include our hypotenuse. And if we convert this into our, I guess the actual format, it will be c squared from our formula. That is equal to our a squared, which is our legs. We can say it as the, I guess, legs 2 or size, plus our b squared, which is right over here. This is what the actual formula of our Pythagorean theorem is. So we talked about the second one, which is the definition of formulas, as well as formulas of our Pythagorean theorem. And it was not important when it comes to solving this question, but the only reason why we did it is because Pythagorean theorem, we can see that it is also one of the origin that created our trigonometric function values. So let's actually go to the third one, which is the properties of different types of quadrilateral shapes, which were going to be our steps that we actually apply to solve our questions. So we can see what is the question about. This question is mainly about the trigonometric function. So here's the trigonometric function. Let's label every single thing that is related or the important thing in our trigonometric function. Well, we know that the trigonometric function is a thing that we can only apply in our right triangle. And what is the most important thing in our right triangle? Well, it is the most important thing in our right triangle will be an angle. So this will be what we do in our right triangle. And what should we do off the right triangle except for the angle? We need to label the size. Well, as we can see, this problem is about the quadrilateral shapes. What is a quadrilateral? So let's write it down. So this will be a definition. Definition of what? The definition of our quadrilateral. So definition of our quadrilateral. What is the definition of our quadrilateral? Well, it is obviously going to be a shape. But what shape is it? 4 shapes. So we were going to be not 4 shapes. It will going to be a 4 sides with 4 angles. We call it shape. 4 sides with 4 angles shape. And what do we call this? We called it as the quadrilateral. So we call it as the quadrilateral. So this is the definition of our quadrilateral. That is the main question in our question in the trigonometric function. So We know that the most important thing in our trigonometric function is our right triangle angle and then the label. So firstly, let's label every single size we can possibly do in order to get more, I guess, information from it. Well, the most important thing about our properties, so we can call the fifth one as the property. The properties are in the this will be a parallelogram. And what is the parallelogram? Well, it is a four angles with the four sides, which has the two pairs of parallel side. And what is the parallel side? Well, it's a side, if we connect a line, it should be exactly 90 degrees. And we need to think about the properties through this property, parallel side. Well, we know that if we do a parallel side, the sides should be always equivalent together. This is the main priority, or I guess the thing that we need to know before we apply this to our quadrilateral, especially to a parallelogram in this case. So, if you talk about it, this is a 4 centimeter, which means this one should also be a 4 centimeter. And the reason is because this is an angle, this is a point A, this is a point A dash. The reason why we call it as A dash is because this one intersects with the point A together, overlaps. That means this the area right over here should be exactly equivalent with the area right over here. So if this is 4 centimeter, this one should also be a 4 centimeter. Do you know the reason? Because the reason is because they are the parallel. So the way to mark that they are parallel will be the sign like this. And we know that this side is also parallel to this side since we knew that they are the parallelogram. And what is the side of this side? Well, it should be a 2 centimeter. Why is the 2 centimeter? Because of the A dash, the B dash intersect with the A and the B. So if it's 2 centimeter, this one also going to be a 2 centimeter. So if it's 2 centimeter, we can think about in this way. The x degrees is right over here. But the most important thing in our trigonometric function, sine, cosine, as well as tangent. And if you go more advanced one, let's say calculus, we'll be able to learn 3 more. But the most important thing in this case will be our right triangle, because we can only apply our trigonometric function values to our right triangle. So we can talk about it in this way. We need to at least create one or make one, which means we need to manipulate some things in order to create a right triangle. And how do we do it? Well, we know that this is the x degrees. So from this point F, if we connect a straight line to go up, it is a little bit small, but this will be a right triangle. And since we knew that this angle right over here is a vertical angle with our x degrees, what is the vertical angle? We can see that vertical angle always should be exactly equivalent together because they are the verticals together. So since we knew that they are the vertical angles, the x degree should be exactly same with the angle E. So using the properties, we create a right triangle. So if we magnify, this right triangle right over here, well, we know that it will going to be a specific triangle that satisfy its own equation that it has, or the area equation. So if we see that it looks something like this, the right angle. So the side right of the angle right over here will be our x degrees. The angle right over here, will be an x degrees. So we're trying to solve for the tangent of our x degrees. What is the definition of our tangent x? Well, it will going to be the opposite sign. We'll just write it as the sine of x degrees over the cosine of x degrees. This is what the tangent definition will going to be. So if you apply, the only thing that we need to have will be the side that is adjacent right over here and the side that is opposite, which is right over here. So the side right over here, so I will erase this a little bit to see in a better one. Side right over here, that is opposite side, which will going to be our sine of x, will be a 2 centimeter. The reason is because we know that x degrees right over here, the opposite side is right over here, which is parallel to the A and the B, so it will be a 2 centimeter either. So this will be a 2 centimeter, so it will be 2 over our cosine of x, which will be right over here. In order to solve for it, we need to label every single side that we possibly can. We know that this is a right triangle that will be useful when it comes to solving this question. And if this is a 4 centimeter, this is a 2 centimeter, this side for here, we can use it through our Pythagorean theorem. We know the Pythagorean theorem is a squared plus b squared plus, is equal to c squared. So let's erase this from our spaces. So we will erase this a little bit to form our spaces to calculate our Pythagorean theorem. And we know that our Pythagorean theorem is a squared plus b squared is equal to c squared. Our c squared, which is our hypotenuse, in this case, will going to be our 4, because it should always be opposite with our right angle. Opposite with our right angle. So it will be a 4 centimeter, which means 4 squared is equal to any side will be the 2 centimeters. So we'll just call A as 2, so it'll be 2 squared plus b squared. All you have to do in order to solve b is simplify these expressions. And what is the 4 squared? It will be 16 is equal to 4 plus b squared. All you have to do in this case, subtract 4 to the both side, and we're going to get 12 is equal to b squared. And in order to solve for b, all you have to do is take a square root or a square root to the both sides, and we're going to get b is equal to square root of 12. So our b right over here will be square root of 12. So how can you solve this line right over here? Well, all you have to do is add the whole lines and subtract this line with this line. What is the whole one? The whole one will be this line, which is 4 centimeter, plus square root of 12. And what is the square root of 12? So what is the square root of 12? We didn't really have to do this. The reason is because we can use our Pythagorean theorem again. Well, we know that this is a 2 centimeter, and our hypotenuse will be our 2 centimeter too, which means the hypotenuse and this line should be exactly, I guess, parallel. And this one right over here will be something. And if you do it, you can see that 2 squared is equal to 2 squared plus something, and we need to do 0 squared. So this one will be 0. So it will going to be tangent of our sine of x. Sine, what is it? Is 4. Sorry, 2 over our cosine of x, 0, which will going to be tangent of 0. The question is a little bit wrong because the length of the actual point in our between points should be exist, which means you should always pick the value 0. But the whole point is that if you can know what is the trigonometric function, which is the origin, and our Pythagorean theorem, which is one of the biggest, more important things in our geometric function problems. And we also thought about what is the properties of our quadrilateral shapes. So in the next video, we're going to talk about another advanced SAT Level 2 trigonometric function problems.